It's fine, right? Recording started. Put a message in the group. Okay. Yes. Yeah, I am waiting for a few more students. Those who have joined, please wait for 3 more minutes. We'll start the class exactly at 12 o'clock. Please inform your friends to join soon so that we can start the class exactly at 12 o'clock only. Okay. Yes, students, please make sure that every time you will be joining 5 minutes early to the class so that we can clear all the technical things and we'll be starting the class exactly on time. Not only for chemistry class, for every class you should be ready in the class 5 minutes before. I hope all of you have the chemistry link. It's shared in the group. Please check it and join it. Please unmute yourself. Please mute yourself in the class to avoid the distractions. Make sure that you are on mute.
I will wait 2 more minutes, okay? Student will join.
Yeah, yes, I will wait. Yes, it's 12 o'clock, the time up for the chemistry class. I want all the students to join fast. Please have a talk with your friends. Make them to join as early as possible. We don't have time. This is crash course. We have to start the class and have to finish exactly on the time that is mentioned. Yes. We'll wait one more minute. Okay, before that I want to just clear my audio and good afternoon all students. Yes, I want to check my audio and video clarity. I think yesterday there was some technical issue. Today I want to clear that one before the class. Tell me in the chat box or send the emojis. Okay, yeah, I'm getting a good response. Yes, I think everything is clear. Yes. Okay. Subhash, can we start the class? Any more students are there to join?
No problem. Please give 2 minutes.
Okay.
To check the student.
Okay, sure.
Students, please stay on the line. Want to join? Some more student will join within 2-3 minutes. If reach 20, you can join. Other student will join.
Okay. I will be waiting for 1 more minutes. After that, I will be starting the class. All of you stay online. Good afternoon, Prathamesh.
Okay, you can start.
Okay. So, yes. Good afternoon all. Yeah. Checking my audio and video. I hope everything is perfectly audible and visible to you. Okay. So as we have discussed in the yesterday's class, today we will be starting the crash course, the one-shot section of the high weightage chapter. And yesterday I have mentioned to you that today we will be discussing the mole concept chapter. I hope all of you had a quick revision of this chapter by the yesterday itself to avoid the difficulty in understanding the crash course. I am telling that crash course will work only if you have a good idea about have a little bit idea about chapter. If you don't have any idea about chapter, it will be difficult for you. So the first one I want to say all of you is that before timetable already it is mentioned in the group. So before the class, everyone has to be ready with that chapter so that we can run this crash course of the chapter or the one shot of the class very smoothly as possible. Okay. So yeah, let me start the class. Today we will be discussing about the mole concept chapter, and yesterday itself I have said you the weightage and everything of this chapter. Let me go through it one more time, that 1 to 2 questions you can expect from this chapter. And the important topics that we will be discussing is mole, molar mass, Avogadro number, empirical and molecular formula, stoichiometry, limiting reagent and concentration terms. So first we will be discussing about the first topic, then we will be having a conceptual question, then we will go to the concept again, then conceptual question. Like that we can move for this chapter. Okay. Yes. So shall I move? Are you all ready with the class? Everyone, I want response from everyone so that I will be starting it with full energy. Yes, very good. Thank you for your response. Yes, good. Okay. Yes. So students, today the mole concept, the mole part I will be discussing first. Everyone know that what is 1 mole? 1 mole is nothing but anything which is having 6.022 into 10 to the power 23 species. Right, that is if I have a 1 mole of pen. How much pen I will be having? 6.022 into 10 to the power 23 species. That is what the meaning of it. Okay, now the main point of this one is we have to know how to find out the number of moles if you are given with different terms. What are these different terms? First one is the mass. If you are given with mass, this is given mass, and this is volume. If you are given with the volume at STP, that is the main one, at STP. And if you are given with the number of particles, how we will be finding the number of moles? First one, given mass divided by molar mass. M is the molar mass. And the second one, given volume divided by 22.4. Remember that this equation you can apply only if you have been given with volume at STP. That is a very important one. And the next one is number of particles divided by Avogadro number. Okay. Now this is the mole part. Now the another part that you will be asking in the exams is average atomic mass. Average atomic mass, I hope all of you know that it is applicable to the elements which are having isotopes. For isotopes, to calculate the average atomic mass, here is the equation for it. That is sum of percentage abundance into mass number divided by 100. And the equation I can simply write it as A into M1 plus B into M2 by A plus B. What is this A and B and M1 and M2? I will tell you it quickly. That is, example, I am consider an isotope X. Consider an isotope X. What is isotope? Same atomic number, different atomic mass. Suppose it is having a 2 isotopes, X with the atomic mass M1 and X with the atomic mass M2. That is what M1 and M2, the different masses of the isotopes. And what is A and B? A and B are the percentage abundance. A is the percentage abundance of X with the atomic mass M1. And what is B? B is the percentage abundance of X with atomic mass m2. What is this percentage abundance means? It means out of the total percentage of X in nature, a percentage of it is existing in the form of X with a molecular mass m1, and B percentage of it is existing with molecular mass m2, not molecular mass, atomic mass m2. That is what the meaning of it. Hope that was clear to you, right? And what about this A plus B? If I want to write this A plus B, what does it mean? Can I know in the chat box what is A plus B? What is A plus B? Yeah, of course it is 100%. Okay, here is the important formulas from the mole part. Now I will be giving you one simple questions related to the average atomic mass. All of you give a try. Yeah, take a screenshot if you want to know these important formulas. Don't worry, we will be sharing all these things in the group also. At that time also you can go through it. Yes. Okay, here is a question for you. The first question. Yeah, the average molar mass of chlorine is 35.5 gram per mole. The ratio of 35 chlorine to 37 chlorine is naturally occurring. Ratio of 35 chlorine to 37 chlorine in naturally occurring chlorine is close to. What does it mean? What is actually we have to find out? We have to find out the ratio of how much naturally chlorine is occurring in the form of 35 atomic mass and 37 atomic mass. Which means what we have to find out here? What we have to find out here? I hope all of you got an idea. We have to take the ratio of A and B. So all of you just give a try it. Already we know the equation. We have to find out the ratio of A is to B only. All of you give a try. I will be solving this question soon. Just have a try of this question. Yeah, first of all you should make sure that you are remembering the equation. What is the equation? Average atomic mass, which is equal to A into m1 plus B into m2 divided by A plus B. And first of all take out the data that is given in the question. That is, what is m1? m1 will be equal to 35, that is the atomic mass of the first isotope of chlorine. What about m2? m2 it is 37. Now we can easily find out the answer for it. If anybody got the answer, please put it in the chat box. I can see and I can verify the answer. Yes. Option C. Yes, option C. I am getting answer from Kiran. Option C. Yes, 3:1 Sanjay. Yes, very good, very good. All of you got the idea. Yes, thank you. This is the right answer. Very good, all of you. Those who didn't get the answer, I'll be just giving you the idea how to solve it. Average atomic mass. It's already given in the question. That is 35.5. And A we have to find out. A into m1. m1 is 35 plus B into m2. m2 is B into 37 divided by A plus B. Now if you just rearrange the things easily, you can able to find out the ratio between A and B. It will be coming as 3:1. Just rearrange it. It's just mathematical only. Rearrange it, you will be getting the answer 3:1. Yes. Hope all of you got it. Just take A plus B to here in the left side and put it out of the bracket, and then here 35A is there. Take to the left hand side and rearrange it, get the ratio. Yes, I hope this question was clear to you everyone. Is it done everyone? Yes. Shall I move to the next question? Can I get a thumbs up? Yes, Kiran, I got the thumbs up from you. What about others? Yes, Shamida, Pradeep. Okay, yeah, thank you for your response. Yes, okay. We'll be moving to the next concept of the mole only. I want everyone to take a note of this. I hope the screen, everything is visible properly to you. If not, I can explain it. Okay. Now the very important part of the mole concept, that is the conversions. What is this conversions? Most of the questions you can see it will be asking like they will be giving volume, and they can ask any of these terms. They can ask mass, they can ask number of particles, or they can ask anything. How you can easily and timely saving you can find out the answer. just follow this arrow mark. What is this arrow mark is saying? What is this arrow mark is saying? If you are given with volume, if you are given with volume of gas at STP, how you can convert to number of moles? Divided by 22.4 liter. And if you have the number of moles with you, how to convert it back to the volume of gas? What you have to do? Multiply it with 22.4 liter. I want everyone to take a screenshot of it, so that we can easily solve the question. And then the number of particles, number of moles into Avogadro number, we will be getting the number of particles. On reversing it back, what I will be getting? I will be getting number of moles. Same, number of moles to mass. How we can do it? Multiply it with molar mass. Then mass to number of moles divided by molar mass. Okay, I hope this flowchart is clear to you everyone. It's perfectly visible, I guess. Yes. Easily you can solve many questions if you are aware about, or if you can remember this flowchart. Yes. Okay, now based on this I can give you a question. I want everyone to give a try within short period of time, because it's a very easy question. I think I can move to the next one. Yes. Here's a question for you. Calculate the mass of 89.6. Calculate the mass of 89.6 liter of CO2 gas at STP. That is my question. It's a very easy question. Just now only you got the formula how to solve this question. I want everyone to try it. Yes.
176.
Yeah, 176. Very good, Pratham. Yes, I think it's a very easy question. Yes, 176, Kiran. Yes, I am getting answers from everyone, most of the students. Yes, thank you. 176 is the answer. Those who didn't get the answer, don't worry, I will be solving it for you. Here what is asking? Volume is given. And what we have to do? You have to find out mass. How to convert volume to mass? What was the direction of arrow? Volume to mole, then mole to mass. Okay, how we can convert volume to mole? Divided by 22.4. How to convert mole to mass? Multiply it with molecular mass. Okay, and here the volume is given 89.6. Dividing it by 22.4. What I will be getting? The mole. I will be getting the mole as, I will be getting the value 4. I guess it is 4. Okay, now multiply it with the molecular mass of CO2 gas. What is the molecular mass of CO2? It is 44. On multiplying, what I will be getting the mass? 176. Yes, a very simple question, NEET level question. Okay, don't lose any mark from the simple questions. Okay, and don't waste time in this type of question. You have to solve it very quickly, because NEET exam is majorly about the time management. Okay. Yes. Now I can give you one more question for you. Yes. Shall I move? Yes. Here's the next question for you. If you understood the mole part very clearly, you can solve this very easily. How many gram atoms are there in one atom? That's my question. Are you confused with gram atom? What is gram atom? I never heard about it. Anyone is there like that? I never heard about gram atom. Maybe you never heard about gram atom. You might have heard. Yes. Yeah.
Option C.
Option C. Yes, very good. Option C is the correct answer. Everyone got this same answer? Okay. Yeah. I think it's a very simple question, but you might be feeling difficulty because what is gram atom? How it can be connected to one atom? That might be the difficulty you will be facing. Okay, I will be clearing that. Gram atom is nothing but it is another word for mole. It is another way of mentioning mole. That is what gram atom is. Okay, yeah. For atomic substance, instead of number of moles, we can also say it as number of gram atoms. So we all know that one mole will be having how many gram atoms, or 1 mole will be having how many atoms? 6.022 into 10 to the power 23 atoms, 6.022 into 10 to the power 23 atoms. From this we can find out how many moles will be there for one atom. For one atom, how many moles? 1 by 6.022 into 10 to the power 23. 1 by 6.022 into 10 to the power 23. And what is this value? This value is nothing but 1.66 into 10 to the power minus 24. It is equal to 1 atom. Okay. Now I want all of you to just note one more point related to this. What is that? Are you remembering this value, this numerical value, which is nothing but the conversion of 1 AMU to gram. 1 AMU to gram. What is 1 AMU? 1 AMU is nothing but the atomic mass unit, mass of a single atom. And if you want to convert it into gram, which is a numerical value we will be using, 1.66 into 10 to the power minus 24 gram. I want you to note down this also, because question can come based on the conversion. Okay, is it done? Hope everyone understood these terms and this question. If that is the case, I can, yes, thank you. If that is the case, I can move into the terms that is related to this question. Yes, you can just note down the things. Okay, what I already mentioned in the question, the same thing only. In the case of atomic substance, we can express 1 mole as gram atomic mass as well as 1 gram atom. That is what I have given in that question. And in the case of molecules, in the case of molecular substance, we can also tell 1 mole is equal to, or 1 gram molecular mass will be having 1 mole of molecule. 1 gram molecular mass will be having 1 mole of molecule, and 1 gram molecule will be having same 1 mole of molecule. That is what the understanding of this one. Yes. Yes. Okay, I can just take a screenshot of it. And in case of gaseous substance, 1 mole is equal to 22.4 liter at STP. Yes, this is understanding of this one. I hope everyone understood this one. Now we can move for a JE, for a NEET question. And when I am talking about JE, I will recommend all of you, you can solve the JE mains MCQ type questions. JE mains MCQ type questions are very good for the NEET exam. Okay, it will help you to clear the concept. It will help you to clear the concept very easily. Okay. Now here is a NEET 2016 question. All of you read this question, try this question, and get me the answer as soon as possible. Yes. I will be reading out the question for you. Suppose the element X and Y combine to form 2 compounds, XY2 and X3Y2. When 0.1 mole of XY2 weighs 10 gram and 0.05 mole of X3Y2 weighs 9 gram, the atomic mass of X and Y. Atomic mass of X and Y is asking. Yeah, it is not a different question. This question is related to the mole part only. You can try it and you can find it out. Yes. If anybody got the answer, sorry?
2 minutes, sir.
Yeah, sure. I can't give you that much of time because it's a crash course. You can just think how we can do this question. I'm not
Option A, sir, 40 and 30.
Sorry?
Option A, 40 and 30.
Option A, 40 and 30. I know this question will take little bit of time, but it's okay. Yeah. I will be solving it for you, don't worry. Anyhow, when I am giving the question, what you can do is you can just, I won't recommend you, you have to give the answer. There is nothing like that. What you can do is you can just think that, okay, how we can proceed for this question or how we can do this question. That you can do it, and remaining answers, everything, I will be solving it in the class. Okay. Yeah, here I will be solving it for you. Suppose the element X and Y combines to form 2 compounds XY2 and X3Y2. Here we have to find out atomic weights of X and Y. I hope all of you know what is how we can find atomic weights from if you are given with the molar mass, or how molar mass is connected to atomic weight. If I am talking about molar mass of XY2, if I am asking you molar mass of XY2, what it will be? It will be sum of atomic mass of 1x and 2y, right? It is the sum of atomic mass of x and 2y. Am I right? Yes. Now if I am asking you molar mass of x3 y2, what it is? Sum of atomic mass of 3x plus 2y. Yeah. Now using this we can able to find out value of this x and y, small x and small y. Okay, how we can solve it? First of all, find out the molar mass of x by 2. How we can find out molar mass of x by 2? Molar mass of x by 2. It is the number of moles of x by 2 divided by sorry, I'll be right. Okay, divided by mass of number of moles is equal to
100, sir.
yeah, okay, I think it is given mass only. Molar mass of x by 2 is equal to given mass of x y2 divided by number of moles of x by 2. Is it correct? Yes. Okay. And molar mass of x by 2. Given mass of x by 2, is it given? Yes. 0.1 mole. 0.1 mole of x by 2 weighs 10 gram, which means mass and mole is given. From that we can find out molar mass. That is 10 grams divided by 0.1, which is nothing but 100 gram. 100 gram is the molar mass of x by 2. Now similarly, what we can do? I can find out the molar mass of xy3, sorry, x3y2. What it is? It is given mass of x3y3. What it is? 9 gram.
180 gram.
Yeah, in total it will be coming 180. Very good. Yes, 9 divided by 0.05. It is coming 180 gram. Okay, now what you have to do? Substitute all these things into this equation. X by 2, 100. This is 180. 180. Now you got equation 1 and equation 2. Equation 1 and equation 2 you got, right? Now what you have to do? Just rearrange these two equations. What you can do is multiply the first equation with 3 and then subtract it with 2. From that you will be getting the value of x as 40. If you got the value of x as 40, what you have to do is substitute this value of 40 into any one of these two equations and get the value of y, and you will be getting it as 30. Yes. So here is the one. Here is the solution for this question. I hope it is clear to everyone. If you understood this question, it's a little bit lengthier. Please thumbs up. Please put some reaction. I want the response from everyone. Yes. Do some response. Don't sleep in the class. Yes. I want everyone to be active in the class. Yes. I know online class will be little bit difficult, but you should understand that you have only 30 days. How much maximum you are trying for these 30 days, that much easily we can crack this exam. Yes. I want the cooperation from everyone. Yes. Thank you. Okay. Now I will be moving to the next question. An easy question. Easily you can find out. Okay. In which case? It is a NEET 2018 question. NEET 2018 question. Yes. In which case is number of molecules of water is maximum? That is my question. I think most of you have solved this question. Yeah. I just want to convey one concept. For that only I am giving this question. If you have the answer, you can let me know. No problem. You can put in the chat box. Option A. Yeah.
Option A.
Yes. Very good, Lavanya and Prathamesh. Yes. Thank you for your response. Yes. Option A is the correct one. How we can say that option A is correct one? How we will be finding out the number of molecule? We all know that number of molecule is directly proportional to number of moles. More the number of moles, more will be the molecule, because it is just a multiplication and division of Avogadro number, the conversion. Okay. Now 80 ml of water. How many moles are there in 80 ml of water? How many moles are there in 80 ml of water? We know that 80 ml of water volume is given. How to find out number of moles? Can we use the equation given volume? Can we use the equation given volume by molar 22.4? Can we use that? Can we use that? No, right, we can't use that one. Why? Because, yeah, we can't use that. Yes, we can't use that one. Why? What is the reason? Because there is no STP. STP is not mentioned here. Then how we will be solving this question if STP is not mentioning? We know that density of water. We know the density of water. It is 1 gram per ml. It is 1 gram per ml, which means 1 ml of water will be having 1 gram of water. 1 ml of water will be having 1 gram mass of water, and which means 80 ml will be having 18 gram of water, and 80 gram water will be having how many moles? 18 divided by 18, which is equal to 1 mole. Yes. Now what about the second one? 0.18 divided by 18.
10 minus 10 by minus.
Yeah, 10 to the power minus 2 only. And the remaining you can find out. 0.00224 liter of water vapor at 1 atm and 273 Kelvin. Here they have clearly mentioned 1 atm and 273 Kelvin, which is the condition of STP. What we will be doing here? Yeah, given volume 0.00224.
Minus 4.
Yeah,
Divided by 22.
22.4. Yes, very good. Yeah, here we are getting 10 to the power
Minus 4.
minus
Minus 4.
4. Yes, very good. Now the last one, it is already mentioned 10 to the power minus 3. Among these, all these we can see the highest number of mole is first one only. So that is the answer. And what is the number of molecule of 18 ml of water? If I ask you what is the number of molecule of 18 ml of water? So mole is 1 mole. What is the number of molecule? Just multiply it with Avogadro number. Yes, 1 mole into Avogadro number, you will be getting the number of molecule, and 1 mole into Avogadro number for atomic species, you will get number of atoms of it. Okay. Yes. So this is about the mole part. I am winding up the mole part, and I will be moving into the next part of this chapter, that is empirical formula and molecular formula. Okay. Yes. Hope that mole part was clear to everyone. If it is clear, just put a thumbs up by everyone. Yes. Thanks for your response. Very good. Thank you. Okay. Now we will be moving to the empirical formula and molecular formula. First of all, we'll go. All of you know the definition of empirical formula. What is the definition? It will be telling you the simplest whole number ratio of number of atoms present in a compound. Okay, that is what empirical formula. But the thing is, there will be a question in which calculation of empirical formula will be there. How you can solve that question? Follow these steps. Yeah, follow the steps. What are the steps? First you have to find out the molar ratio. How you will be finding molar ratio? Atomic percentage of the elements in a compound divided by the atomic mass of it. That is what molar ratio. Percentage of the element will be given in the question, and molar mass, that also might be given in the question, but if it is not also, they will be giving the question for the elements that are familiar to you. Okay. Yes. Now the next step, first one, once you find out the molar ratio, the next one is convert it into simplest molar ratio. Convert it to simplest molar ratio. How we can convert to simplest molar ratio? Divide all the molar ratio value. Divide all the molar ratio with the lowest molar ratio that you got for the elements in the compound. Divide it with the lowest molar ratio value that you got for the element. Okay. After doing that, what you have to do next one? Convert it to the simplest whole number ratio. We have to convert it to simplest whole number ratio. How you will be doing that one? Multiply it with an integer. Multiplying it with an integer. Yes. Then you can write on the result. That's only. I will give you a question. I know that, okay, remembering this will be difficult. Don't worry, I will be giving you a question. I will be giving you a question that is helping you to remember these steps also. Okay. Yeah. Sorry? I didn't get you. yeah, can you make the conversation in English? I am not that much comfortable in Hindi. Repeat. Okay.
Repeat.
Okay. Was the audio? There was an audio issue. Okay, I will repeat it. What you have to, okay, don't worry about this one. I will be giving a question. From that, it will be clear. These are the steps that you have to follow. To find out the empirical formula. First one, you have to calculate the molar ratio. At molar ratio, you will be calculating by taking the ratio of percentage of the element divided by atomic mass. Then you have to convert it into simplest molar ratio. Here you will be getting a value for different elements, right? Here you will be getting a value for different elements. Among that, which value is the lowest value? Which elements you got the lowest value? That value will be dividing it with all the molar ratio. Then you will be getting a simplest molar ratio. Then converting it to a simplest whole number ratio by multiplying it with integer. You will be getting the empirical formula. I will give you a question. Definitely you will be understanding this one. No worries. Can I give a question? Before that, I will tell you what is molecular formula also. Yes.
Wait for a minute.
Okay. You can take a screenshot. Or else no worries. In the next question I will be giving, that you will be having the table of calculation process of empirical formula. Okay.
Done, sir.
Yes, thank you. Yeah. Next I will be giving you the idea about molecular formula. Molecular formula, everyone is aware. I know that, because molecular formula is the formula that we will be using it for everywhere for all the compounds. Okay, and it will be giving you the exact number of atoms present in a molecule or a compound. And there is a relation that I want all of you to note down, that is relation between empirical formula and molecular formula. That is, molecular formula is equal to n into empirical formula. Molecular formula is equal to n into empirical formula. And what is this n? N is nothing but n is equal to molecular mass divided by empirical formula mass. Molecular mass divided by empirical formula mass. Okay. If you found out empirical formula and the question is find out the molecular formula of it, what you have to do is multiply the empirical formula into this value. You can convert it to molecular formula. Okay. Yes. I hope it is done. Now I will give you a question. Yes. Can I? Okay, I will be giving you a question. Just note down these two formulas. Yeah, here is a question for you. Calculate the empirical formula for a compound that contains 26.6% potassium, 35.4% chromium and 38.1% oxygen by weight. This is the question. I said you will be given with the percentage of elements in a compound and you will be asked to find out the empirical formula. Follow the steps. In the slide I have mentioned the different steps to calculate it. If you got the answer, you can put it in the chat box, or else after few time I will be solving it. I will be directly giving you the solution in a table wise. Okay. If anybody got the answer, you can let me know.
K2Cr2O7.
K2? Sorry, K2?
Cr2O7.
K2Cr2O7. Yes, very good. Yes. Just follow the steps, you will be getting the answer. Yes. 227. Yes, I am getting answers from the multiple students. Yes, I am correct. Yes, good. Okay, I think I can move. I will be giving you the solution of it, don't worry, in a table wise. Here is the solution. what you have to do, whatever the steps that I have mentioned in that slide, that I have mentioned over here. Here is element potassium, chromium and oxygen. Potassium, chromium and oxygen, and the mass percentage which is given in the question, that is 26.6, 35.4, 38.1, that is mentioned here. Then the atomic mass of it 39, 52, 16, which is also given in the question. Now what was the first step? We have to find out the molar ratio. What is this is what the molar, this is the molar ratio, that is divide the mass percentage by atomic mass. You will be getting a value. Now you look at here, among these which is the smallest value? 0.68 is the smallest value, right? That value I will be using to divide it with every value. That is the simplest ratio. See here 0.68 I have divided with 0.68. Here 0.68 I have divided with 0.68. Here the 2.38 value that I got, which is the molar ratio of oxygen, I divided with 0.68. I got 3.5. This is the simplest molar ratio. Now what is the next step? Convert into simplest whole number ratio. How to convert simplest whole number ratio? Multiply it with the nearest integer. What I will be getting the answer? 2, 2, 7. This is the answer. Okay. Yeah. So I hope this was clear to everyone. If it is clear, please put a thumbs up. I will be moving to the next topic of this chapter. Yes, thank you everyone for your response. Yes. Okay, now we will be discussing about stoichiometric coefficient and limiting reagent, another important part, high priority part of this chapter. Stoichiometric coefficient, it is just a number. It's just a number telling you how number used to balance a chemical reaction. If you balance a chemical reaction, you will be getting a number, right? Number before the elements. That is nothing but the stoichiometric coefficient. Okay, and how we can understand this stoichiometric coefficient and how it will be using to solve the question. Okay, suppose I am writing the preparation of ammonia, that is N2 plus 3H2 gives 2 NH3, and we know that this is a balanced chemical reaction. After balancing, what you got? You got 3 and number 2 and number 1 here, and this number is nothing but the stoichiometric coefficient, and this stoichiometric coefficient will be helping you to find out the amount of unknown substance that will be asking in the question. How we can understand that one? According to this formula, we can say that 1 mole N2 will be giving 2 mole NH3 and 2 mole NH3 and 1 mole N2 will be giving 2 mole NH3, and the question will be like that: how many moles of NH3 will be forming if you are given with 2 mole N2? What will be the answer? It is 4 mole NH3. 1 mole will give 2 mole, 2 mole will give 4 mole. That is what the stoichiometric questions will be. Okay, same way it can ask about a hydrogen also. That is how we have to deal with stoichiometric question. Okay, and the next question, what will be the next question? Next question will be question related to the limiting reagent. What is limiting reagent? That is, I am doing a reaction, A plus B gives C, and as time t equal to 0, let's suppose the amount is A and this amount is B, and this is 0. After some times, or when the time at equilibrium reaches, what you can see, imagine that any one of the reactant become completely consumed in the reaction. Let's suppose this becomes 0 and this becomes some amount C, and at this point of time we can say the reaction has stopped. The time when any one of the reactant becomes 0, that point of time we can say the reaction has stopped, and that element which completely consumed the reaction or completely vanished after the reaction, we will be calling it as limiting reagent. We will be calling it as limiting reagent. And that element which is there in the container even after finishing the reaction, that we will be calling it as what? Excess reagent. Excess reagent. Okay, this will be the type of question we will be asking. Now my doubt is how you will be finding this limiting reagent. Do we have any simplest method? Do we have any simplest method to find out? Yes, we have. How you will be finding the limiting reagent? Lowest value of the ratio, that is given moles divided by stoichiometric coefficient. Just note down lowest value of given mole divided by stoichiometric coefficient. That will be telling you the limiting reagent. That is, if the given mole of A is A and the number of the stoichiometric coefficient is 1, so the ratio will be A by 1. Here the ratio will be B by 1. Which one you will be getting the lowest value, that is the limiting reagent, and the next one will be the excess reagent. Okay, yeah, I hope you understood. I will give you a question related to it. And one more thing I want.
Please repeat the concept.
Yeah, limiting reagent or stoichiometry?
Limiting reagent.
Okay, limiting reagent, I can't go deep into limiting reagent. I will give you a question related to it and I will be explaining it. I am just telling that limiting reagent is nothing but the amount that is limited in the reaction, that is that element in the reactant which will be completely consumed in the reaction. After some point of time, that reactant will be completely vanished from the reaction. That reactant is nothing but limiting reagent. And how we can find out which one among A and B which is a limiting reagent is, take the ratio of given mole, this will be given in the question, and divided by the stoichiometric coefficient. Which one you will be getting the lowest value, that one is the limiting reagent. Okay, I will give you a question, that time it will be clear to you. I will be giving a question, that time it will be clear to you. Yes. And another thing is that I want to add is, if you are given with a question, how you will understand that you will be knowing if it is limiting reagent question or stoichiometric coefficient question. In the case of stoichiometric coefficient, you will be given with any one amount of reactant. If you are given with only, okay, limiting reagent I can tell, if you are given with both the reactant, then at that time you have to go for limiting reagent concept. If you are given with any one of the reactant, at that time you have to go for the stoichiometric concept. I will give you a question and at that time I can make it clear. Okay, shall I move for the question? Yes. Okay. Yeah, here is a question. I am simply asking what is a limiting reagent. You can easily find out the answer. I will explain it here so that it will be more clear to the students who didn't got it. Okay. I want the answer in the chat box. Following reaction mixture contains 2 mole of H2 and 2 mole of O2. Then the limiting reagent will be, what will be the limiting reagent? Anybody have an idea? That is given mole. What are the given moles?
Option B, sir.
Option B, Haydn, very good.
B.
Yes, option B. Option B is the correct one. Thank you for the quick answer. Yeah. Given mole. What is the given mole? Here is 2 mole is given and 2 mole of oxygen is given. See, here we can see amount of both the reactants are given, which means you have to use the limiting reagent concept only. Okay. Yeah. Now how are we finding the limiting reagent? Take the ratio of it, given mole. that is 2 divided by the stoichiometric coefficient, given mole divided by stoichiometric coefficient, you will be getting a value here, that is 1. And now here given mole 2 divided by stoichiometric coefficient, you will be getting a value 1. What is the value you are getting? 2 here. Among these, which is the lowest value? Which is the lowest value? 1 is the lowest value, right? Which means hydrogen is the limiting reagent here. Here hydrogen is the limiting reagent and the oxygen is the excess reagent. Hope it is clear to you everyone. Is it clear? Easily you can find out. Now one more thing I want to add is, this limiting reagent we will be using to find out the amount of other substance. If you are using the limiting reagent, this is the guy, limiting reagent, he is the guy who knows everything in the reaction, because he is there from the beginning and at the end of the reaction. So he will be knowing that how much amount of oxygen reacted with him and how much amount of H2 has been formed. So whenever you are finding answer for any question, you will be equating everything with limiting reagent. Okay, and this is the excess reagent. Now if I ask you how much excess of O2 is there in the container. If I ask you how much excess of O2 will be there in the container, how you will be finding it? First of all you have to find out how much amount of, yeah, very good, 1 mole. First of all you have to find out how many moles of, out of these 2 mole, how many moles of oxygen reacted with hydrogen. According to the stoichiometry we know that 2 mole of H2 reacts with 1 mole of, yeah, 1 mole of O2. And how many moles of, yeah, how many moles of H2 is there? Okay, 2 mole of hydrogen react with 1 mole of O2, and which means 1 mole of O2 will be reacting with 1 mole of O2 will be reacting with 2 mole of H2, and the remaining excess will be what? Excess will be 1 mole. Okay, that is the amount of excess. 1 mole reacted with 1 mole reacted with 2 mole of H2, and the remaining 1 mole will be the excess reagent. Okay, got it. And next, if I am asking you what is the amount of H2O formed, at that time also you have to equate H2O with H2 only, limiting reagent, because limiting reagent only know how much amount of H2 is formed. Okay, I will give you one more little bit conceptual question so that this will be clear completely to you. Okay, yes, I will be giving you one NEET question. Yeah, all of you give a try. One gram of magnesium, 1 gram of am I audible to you? Hello, is my voice is clear? Yes. 1 mole of, yes, thank you. 1 mole of magnesium is burnt with 0.56 gram of O2. 0.56 gram of O2 in a closed vessel. Which reactant is left in excess and how much? Just now only we have discussed about it, and I hope you can do it. Little bit calculative part is there. Definitely I know that you can do it. First of all, write down the reaction. I will be helping you also in between. First of all, write down the balanced reaction. That is, what is the reaction? Mg plus O2 gives 2 mg. Oh, is it balanced? No. 2 mg plus O2 gives 2 mgO. According to this, we know that 2 mg, 2 mole of magnesium will be reacting with 1 mole of O2 and will be giving 2 mole of MgO. First of all, identify the limiting reagent. Then only you can find out which is the excess reagent. That is what the first part of the question. Yes. If anybody got the answer, you can put it in the chat box.
Option B.
Option B. Okay, first of all,
Option B.
option B. beta?
Option A, sir. Option A.
Option A. I am getting multiple answer. Option A, option B. Okay. Anyone else is there with the different options?
Option A.
Option A. Yeah.
Yes, sir.
Option.
A.
Okay. Option A. Yeah. I think most of you are going with the option A. Yeah. We can see what is the answer. It is a little bit calculative, so that is why you might be facing difficulty. Anyhow, you can cancel out the options. You can cancel out the option if you found out the excess reagent, right? That is the first and main thing you have to do. Then it is a 50% probability. Okay. First of all, we can see which one is a limiting reagent and which is the excess reagent. Okay. How we will be finding the limiting reagent? First of all, we should write the number of moles. Initial number of, okay, initial number of moles. What is initial number of moles? Here the mass of magnesium is only given, so you will be finding out the number of moles. 1 by 24. 1 by 24. What will be the value coming? And here oxygen 0.56 divided by 32. Okay. And here you will be getting the number of moles value as 0.0416, and for oxygen you will be getting the value as 0.56 divided by 32. What it is? 0.0175 moles. 0.0175 moles. Okay, this is the number of moles. Now to find out limiting reagent. What you will be doing? Divide this number of moles divided by the stoichiometric coefficient, that is 0.0416 divided by stoichiometric coefficient, that is 2, and here it will be 0.0175 divided by the stoichiometric coefficient, that is 1. Okay. From this you will be getting the smaller value. You will be getting the smaller value, that is magnesium. Smaller value, that is oxygen. If I am doing this, you will be getting the smaller value of this one, that is oxygen. Oxygen is the limiting reagent. If oxygen is the limiting reagent, then magnesium is the excess reagent. So this is our excess reagent, and oxygen is our limiting reagent. The question is excess reagent only. Okay. Now after this, what you have to find out? You have to find out how much excess. Yes. How much excess is there? How we can find out how much excess is there? According to the stoichiometry, we know that 2 mole of magnesium will be reacting with 1 mole of O2. And how many O2 is there? How many moles of O2 is there? 0.0175 mole of O2, which means 0.0175 mole of O2 will be reacting with 2 into 0.0175 mole of magnesium. This is the number of moles of magnesium reacted with oxygen. But the question is not that. What is the question? How much of magnesium is there will be there excess or left out in the container? If this is the reactant and this is the total number of moles, how we can find out? Yeah, excess magnesium, that is total moles, 0.0416 minus 2 into 0.175. You will be getting the answer as 0.000066 mole of magnesium. 0.0066 mole of magnesium. Is it? Am I got my answer? Did I get my answer? No, right? The question is not about mole. The question is about mass. How much, which reactant is left in excess and how much. Everything is given in gram, which means I have to convert this mole into mass. How I will be converting mole into mass? mass of magnesium in excess. Number of moles into 0066. Number of moles into molar mass of magnesium, that is 24. You will be getting answer as 0.16 gram. Okay, this is how we can solve this question. It's a little bit time consuming question, but easy question only. If you understood the concept of limiting reagent, it is an easy question only. Okay, at least you can find out a 50% probability if you found out which one is excess reagent. Okay, you can cancel out the option B and D, and then yeah, if you want to go for a guess, you can go for a guess also, no problem. Yes. Okay, I hope this question is clear to you. We can move into the next part of this chapter. Yes, give me the response, give me the response. I will be moving into the next one. Small topic is there, not one small topic. Yes. Okay, next one I want to discuss you about percentage purity. Percentage purity question can connect with a stoichiometry question. Okay, for that I am just giving you a clarity of it. Just take a screenshot or take a note of it. Percentage purity will be telling you out of the total percentage of the amount present in a sample, how much pure sample, how much pure element or pure compound is there. That you will be telling by percentage purity. And how we can calculate it? Mass of the pure compound. How mass of the pure compound divided by mass of impure sample. Mass of impure sample into 100. Like this we can find out the percentage purity. Just take a screenshot of the equation. I will be giving a question related to it. We can solve it togetherly. Okay, it will be at least if I am telling you 20% of 20 gram or 20% of 100 gram only is pure, which means how much will be the pure? The 20% of 100, that is 20 gram is only pure. That is how the meaning or understanding of this one. I can give you a question. Shall I give you a question? A NEET 2023 question which came related to this part. Yeah, this is the question. All of you give a try and get me the answer as soon as possible. Yes. If anybody got the answer, you can put me in the chat. The right option for the mass of CO2 produced by heating 20 gram. By heating 20 gram of what? 20 gram of 20% pure limestone. Limestone is CaCO3. Limestone is CaCO3. And remember that only the pure amount only will undergo the reaction. Impurities won't be undergoing the reaction, which means the pure limestone only will be undergoing this decomposition. Yes.
1.76.
1.76 is the answer I am getting from Prathamesh. Anyone else? You want to give answer? Anyone else want to go for the first answer? Yes. If anybody want to go for any options, let me know. I'll be going with that. Okay. Or else I think I can solve it. First of all, you should know that what we have to find out this question. What thing we have to find out in this question? In this, we have to find out the CO2, mass of CO2. How normally we will be finding the mass of CO2? How we will be normally finding? Using the stoichiometric coefficient. Using the stoichiometric coefficient, because here there is only amount of only one reactant. There is only one reactant, and we don't know whether that reactant will completely consume in the reaction or not. Completely consume in the reaction or not. So we will be going with the stoichiometric concept. Limiting reagent, this itself will be the limiting reagent, even if it is completely consuming. Okay. So according to the stoichiometry, what is there? 1 mole CaCO3 will be giving 1 mole CO2, right? And 1 mole CaCO3 is having how many gram? If I want to convert it to gram, 1 mole means the molar mass of CaCO3. What it is? What it is, dear students? It is, I think, 100 gram. 100 gram. 100 gram will be giving 44. Yes, 44 gram of CO2. and which means 1 gram will be giving how many grams of CO2? 44 divided by 100 gram CO2. Okay, now my question is, how many gram of CO2 CaCO3 is undergoing the decomposition? That is what we will be getting it from 20% of 20% of 20 gram CaCO3. Okay, what is the 20% of 20 gram CaCO3? What it is? 20 divided by 100 into 20, that is 4 gram. That is out of, yes, so out of the 20 gram sample, only 4 gram of limestone is only undergoing this reaction, which means now we can easily find out how much amount of CO2 is forming. That is 4 gram of CaCO3 will be giving how many amount of CO2? 44 divided by 100 into 4. The answer is coming 1.76 gram. Here is a simple way you can solve this question. Keep these things also in your mind. Whenever the question they have asked mass, what you have to do is convert the things into mass and try a method for finding the answer. Okay, got it? Everyone understood? Can I move to the next?
Yes, sir.
Next, one more question. Let me see if questions are okay. Yeah. Okay. Now most of the things has been covered. Now I will be going into the last part of this chapter. That is the very important one. Yes. What is that? Concentration terms. Concentration terms. Concentration terms. We have the different concentration term. The first concentration term I want you to take a note of is percentage by mass. Percentage by mass. The concentration term expresses the mass of solute as a percentage of total mass of solution. Weight by weight percentage. It is, the equation is nothing but mass of solute divided by mass of solution into 100. Remembering the equation is very easy. Here next term is mass by volume percentage. Mass by volume percentage is mass of solute divided by volume of solution. Whatever there in the numerator and denominator, the same is there in the numerator and denominator of the equation. Okay, and remember one thing that I want you to just be conscious is, here everything is in gram. Here it is gram, and here everything is in, and volume will be in ml. Volume will be in ml. Percentage terms, volume will be in ml and mass will be in grams. That is the one thing I want you to take a note of it. Okay, done? Okay, now one more thing I want to say is, I want to know what is the meaning of this. What is the meaning? If I am just telling you 20% weight by weight or mass by mass of aqueous glucose solution. Aqueous glucose solution. What does it mean? What does it mean actually? It means 20 gram of glucose in 100 gram solution. 20 gram of glucose is present in 100 gram of solution, and as it is aqueous solution, the remaining 80 gram is water. Okay, this is the meaning or the decoding statement of 20% weight by weight. Got it? Yes. Now one more thing I want to add is, sometimes in the question you might have to convert this total mass of solution into volume. How we can convert this total mass of solution into volume? How we can convert? You have to mass into volume. Yeah, anyone? We know the mass and volume formula.
Density formula.
Yes, very good. It's a density formula. So what I will be doing? I will be dividing it with density. So this is one thing I want to note. If you want to convert mass to volume, divide it by density. Volume to mass, multiply it with density. Same thing here also. Yes. Done, everyone? Yeah. Now we'll be moving into the next concentration term, that is percentage volume by volume. volume by volume, here also volume of solute divided by volume of solution, and then ppm, ppb and ppt. Just take a screenshot. I know all of you are aware about all these equations. One thing I want to note down everyone is it is in ml, volume in the case of percentage, volume is in ml and mass will be in grams. Okay. And next is ppm. ppm is mass of solute divided by mass of solution. It is similar to, it is same as that of mass by mass percentage. What is the difference? What is the difference? 10 to the power 6. In the case of ppm it is 10 to the power 6, ppb it is 10 to the power 9, and ppt is 10 to the power 12. That is the one I want to note down. This ppm, ppb, ppt we are using when the amount of solute is very less. If the amount of solute is very less, at that time we will be using ppm, ppb, ppt, everything. Okay. Yes. Now I will be giving you the questions. Okay. Before going to the question, one more thing I want to note down. That is the two important concentration terms. That is molarity and molality. Everyone is aware about these equations. I know it. Number of moles of solute, number of moles of solute divided by volume of solution in liter. That is molarity. And remember that here it is. When it's coming to the molarity and molality, the unit will be changing. Volume will be in liter and mass will be in kilogram. That is the two things I want to note down. Don't confuse with the units in the previous one and the here. Okay. Yes. Yeah. Number of moles of solute divided by mass of solvent in kilogram is the equation for molarity. Yes. If you are done or taking note of this, I can go with the question. The last part of this chapter, the concept, it is over. Now we will be moving into the questions. Already we have discussed lot of PYQs. Still few more PYQs I will be giving you depending on the time. Can I move? All of you done?
Sir, can you discuss normality?
Sorry?
Can you discuss normality?
Yeah, normality will be number of gram equivalent. Anyhow, normality we will be discussing it in the redox chemistry chapter. That's why I have not mentioned here. Number of gram equivalent divided by volume of solution in liter. That is what normality. Here instead of number of moles, it will be replaced by number of gram equivalent. That is what normality. Okay. Yes. How to calculate the number of gram equivalent and everything, we will be mentioning it in the redox chemistry chapter. And also there is a relation between normality and molarity that is related with the n factor. All these things we will be discussing it in the redox chapter. Okay.
Okay, sir.
Yes. Okay, one more concentration term is that is mole fraction. Just take a note of it quickly. Yeah, mole fraction, out of the total fraction, how much fraction of a particular component is there in a solution. That is what mole fraction. Everyone is aware about this equation, I know it. Mole fraction, it is equal to number of moles of the solute divided by total number of moles. That is in a solution, if they have two components A and B, how much out of the total fraction, how much fraction of A is there? That is chi A, mole fraction of A. And out of the total fraction, how much fraction of B is there? That is chi B. And remember that the chi A plus chi B, chi A plus chi B, that will be 1. Okay. Yeah. Mole fraction equation, just go through it. Now I will be giving you the question, solve it. Yeah, all the concept of this chapter is over. Now we will go to the question. If you are ready for the question, just put a thumbs up. I will be moving. Okay. Yes. Yes, thank you for your response. Okay, here is a question for you related to the concept that we have just discussed. Give a try, everyone. Calculate the molarity of 20% weight by weight NaOH solution. Density of solution is 1.2 gram per centimeter cube. Centimeter cube. Centimeter cube. Gram per centimeter cube. What is it? Are you getting some confusion in that? Well, gram per centimeter is nothing but it is 1.2 gram per ml. 1 centimeter cube is equal to 1 ml. Let me know the answer. Take some time to find out the answer and get it. Don't make mistakes. If anybody got the answer, you can solve it. Here I am asking the molarity. I will write down the molarity equation. What is molarity equation? Number of moles of solute divided by volume of solution in liter. The two things that you have to find out is number of moles and volume of solution in liter. Yes. First of all, I want all of you to decode this. What is this? 20% weight by weight. 20% weight by weight of NaOH. What does it mean? What does it mean? 20 gram NaOH. 20 gram of NaOH in where? In 100. Yes, 100 gram of NaOH solution. Yes. Now from this we can easily find out the number of moles of NaOH, right?
6 molar. Answer is 6 molar.
Answer is 6 molar. Yes, very good. Answer is 6 molar. I got the answer from Prathamesh. Anyone else is agreeing with the same answer? What about remaining? Yes. Many others are also saying the same answer, right? Okay. If it is the same answer all of you got, then I can move with the solution of it. Yeah, you are right. Number of moles of NaOH, it is 20 gram divided by molar mass of NaOH. What is the molar mass of NaOH? Molar mass of NaOH, it is 40, right? Yeah, here you will be getting the number of molars 1 by 2. I can substitute that 1 by 2 over here. Okay. Now the next part is you have to find out volume of solution. But what we have? We have only total mass of solution, and just now only I have said you how you can do this conversion. How you can do it? Convert it to volume by dividing it with density. That is 100 gram divided by, what is the density? Density, mass is 100 gram divided by density, it is 1.2. What is the answer? Yeah, what is the answer you are getting? Okay, here you will be getting the answer in gram per ml, right? Here you will be getting the answer, here you will be getting the answer in ml, 100 by 1.2 ml, but in the question we need the answer in liter. So what I will be doing is I will be dividing it with 1000 and you will be getting, you can convert it to liter. Okay, I think I will be getting the answer 1 by 12 liter. Now substitute this 1 by 12 here. 1 by 2 divided by 1 by 12, I will be getting 6 molar as the answer. Is it clear to everyone? Is it clear?
Yes, sir.
Yes. What about others? If it is clear, or if you have no doubt, you can ask why these things comes, or how it come, or how it came. Yes, thank you for your response. Yes, can I move for the next question if you are ready? Are you guys tired? I know that you are staying in the system. Yeah, thank you. You are staying in the system from the last 3 hours. It will be difficult, but we have no other options. We have to sit. Yeah, we have to sit because your exam is there. You should set your mind. Okay, yeah, I hope everyone is ready for the next question and is very active also. Yes. Here is the next question. Yeah, a solution is prepared by adding 1 mole ethyl alcohol in 9 mole water. Just a minute. I want to give one question before it. Okay, I want to give one more question before it. Okay, solve this question first. Here you have to find out both molarity and molality. 49% weight by weight solution of H2SO4 in water has a density of 1.2 gram per ml. Calculate the molarity and molality. Yes. Similar to the previous question, but there is a difference that here you have to find out molality. Take a try, get me the answer in the chat box. If you got the answer, let me know. Anybody got the answer? I think easily you can find out the molarity.
The molarity is 2.45.
Molarity is?
Molarity 2.45.
Molarity 2.45. Check it once again. Number of moles of solute divided by volume of solution in liter. This is molarity. And what is equation for molality? Number of moles of solute divided by mass of the solvent. Okay, mass of the solvent in kg. Number of moles, that is the first thing that you have to find out. For that, what we can do? 49% weight by weight of, sorry,
Molarity is 6.
yes, very good. Molality is 6. Molality, what about molality?
Molality is 9 point.
Molality is 9.8. Yeah, very good. Yeah, hope all of you got it. Yeah, very happy to get the answers from everyone's. Yes, I'll be solving it for the remaining. 49% weight by weight of H2SO4. What is the meaning? 49 gram H2SO4 in 1000 gram solution. From this we can find out the number of moles of H2SO4, which is equal to 49 divided by molar mass of H2SO4 98 is equal to 1 by 2. I got the number of moles. Next thing is number of moles, 1 by 2. 1 by 2. What is the next thing? For finding the molarity, I have to find out volume of solution liter. 100 gram converted to volume. The same thing that we did, same density also here. Okay, 100 divided by 1.2 into 1000. You will be getting the volume in ml. It will be 1 by 12 ml. Okay, yeah. So I will be getting the answer 1 by 12 here. It is equal to 6 molar. Okay. Now what is the next thing? Weight of the solvent. Weight of the solvent. How we can find out the mass of the solvent or weight of the solvent? Mass of solvent is equal to what? Mass of solution minus mass of solvent.
51 gram.
Yes, here it will be coming 100. Mass of solution, it is 100 gram. 100 minus solvent. What is solvent? Solvent is 49. Sorry, it's not the mass of solvent, it is mass of solute. Mass of solute 49 gram of H2SO4. 49 will be coming 51 gram. Okay, now I have to convert it to kilogram because this is in mass of solvent in kilogram. 0.051 kilogram. Yeah, substituting over here 0.051 kilogram, I will be getting the answer around 9.80 approximately. Okay, yeah. Are you got everything? Are you clear with this question? If you are clear with this question, put a thumbs up. Yes. Any more doubts you have with this question? Or yes, thank you. Yeah, now this is the main thing in these questions, that is volume conversion and conversion of mass and finding the solvent from the solution and solute. So this is small things, you can easily find it out and you can solve these questions, this type of questions. Okay. And there is a direct formula also to find out molality from molarity. I am saying formulas always you won't be remembering. You won't be remembering the formulas, right? Then what you will be doing? You have to solve it by the direct method, which is more accurate. Okay. Now here is another question for you, the NEET 2024. And this is the last question for you. Remaining questions I will be sending you through my PPT. Okay. I want the answer from you. This is the 2024 PYQ question. Yes. Option A. Yeah, I am getting answer from Kiran. Kiran saying option A.
Option A.
Option A. Yeah, quite very
Option
easy
A,
question.
sir.
Yeah, it's a recent year question, but still all of you got the answer very quickly. So that's a beauty of NEET exam. Answer you will be getting it very easily. All are simple questions only. Only thing is that you have to remember, you have to do proper revision. That is the main thing or main strategy behind the NEET exam. Revision. Now in this 13 days, what you have to do is you have to do the revision. You should not lose a single mark from the chapter that you know. That you will be doing through a proper revision of everything. New contents, this is not the time to learn new contents, because that will consume too much of time, and when you start learning new contents, you will be forgetting the remaining things. That is why whatever you have learned, make sure that you will be able to solve the answer from that content at any cost. Okay, so I hope this is very clear. This question is very clear. The highest number of helium atom, number of atom is directly proportional to the number of moles. Yeah, here it is 4 mole, and here it is 4 U of helium. What is U? Atomic mass unit. How we can find out number of moles of this atomic mass unit? How we can find out? Convert it to gram, which I mentioned in the beginning of the class. How we can convert it? 4 into 1.66 into 10 to the power minus 24 gram. Then divide it by the mass of helium, that is 4. You will be getting the number of moles, which is very small value. Approximately we can say it is equal to 1. And here 4 gram of helium, 4 by 4, it is 1 mole. Sorry, it is approximately equal to 0. And 2.27108 divide of helium, what it is? 22.4 liter. You will be getting the number of moles, which is coming around 0.1. Okay, so among these the highest value is A. So that is the answer. Yeah, very good for the answers for the students who have given the answers correctly. Remaining few more questions are there. I will be sharing that one with you also. All are easy questions only. I hope all of you understand this. All of you understood the chemistry concept clearly. If you have any doubt, you can ask in the WhatsApp also. You can send the screenshot of the question if you have any doubt. Everything will be clearing it. Don't worry. And I want all of you to be stay focused and prepare properly. And after every classes, what you have to do is you have to solve the questions from the chapters that has been taken by each and every teacher. It should not be like you have to give more time to one particular subject. You have to equally distribute the time for all the subjects. Okay, and you have to properly do a revision and PYQ solving as well as the DPP solving. Then only you will be able to get confidence before the NEET exam. Okay, so this is the end of the class. Hope everything was clear and perfect for everyone. Tomorrow we will be seeing you with the next chapter, that is atomic structure chapter. Everyone has to be here on time. I want everyone to be here in every classes 5 minutes before, so that we can start the class exactly at the right time that is mentioned in the group. Okay. Yes. Yeah. Now the next class will be the biology class, and the biology class will be happening at 3 o'clock. Everyone should be here at 2:55 in the online. The teacher should take the class or start the class at 3 o'clock. Time is very important. We can't wait for every students to come and join. That's why I'm telling you to be on time. Okay, so that's the end of this class. We'll see you in the next class. Yes, bye everyone. Thank you.